I should lose my
All right.
mind.
I didn't have that bad of a time.
So, like I said, for right now, I'm just going to try to get through the highlighted ones. So, we're going to pick a pretty color. Purple. All right. In statistics, number 2, what is meant by probability? Okay, it's the likelihood of something happening okay, and it is when the probability is between 0 and 1. Or probability is between 0 and 1.
0 means never, 1 means always.
Yep. What does it mean for trials to be independent? That means that the outcome of one trial does not affect the outcome of other trials. Yes. Well, with replacement. Because then one doesn't affect the next one.
I'm saying not independent. They're independent.
Well, if you take an ace and you don't put it back,
Yeah, that affects the probability.
then that affects the probability of the next one occurring.
Yeah.
Because then you only have 3 left out of 51.
Yeah. So
Instead
that's
of your
not-
original 4 out of 52. If you replace it, then it would be independent.
I was
Yeah.
talking about not independent.
Yeah, then it would, yeah.
No.
Yeah. All right, number 6. Explain why the probability of any event is a number between 0 and 1. Okay, 0 is that it happens 0% of the time. Meaning never. If it's 0 less than or equal to the probability of A, I guess it really should just be less than 1, okay, meaning that it's anything between 0 and 1, then it happens sometimes. So, again, your key to think about is sometimes it can happen. If it's 1, then it happens 100% of the time. In which case we're looking at always.
I actually knew that. Like, that was like something I was confident about.
All right, 9, we'll be doing 9 through 12. So 9, what is meant by the complement of an event?
Everything outside the square.
Okay, it's the set of outcomes not in the event, okay, outside of the circles, okay.
Yeah, circle. Same thing. Same.
I know what you meant.
Thank you.
Set of outcomes not in the event. Okay, so between 8 and 9, you would have, we're obviously not doing 8, but you'd have something like A, then outside of it is A complement. Okay, it means everything outside of it. Number 10, when are 2 events considered disjoint?
When they're independent.
Okay, meaning what?
They don't affect each other.
No overlap, nothing in common. No outcomes in common. Meaning no overlap. Okay, another name for it is mutually exclusive. Okay, if you basically just tell me no overlap or nothing in common, that would be sufficient. Just so you have a picture of it, that would be something like two separate circles and you've got A and you've got B with nothing overlapping. The probability of two disjoint events, okay, is implying it's an OR problem. So the probability of A union B is equal to the probability of A plus the probability of B, okay? This is the addition rule. It only works for disjoint events. Now, what I want you to remember is that we also have a probability rule, addition rule, okay, for events that are not disjoint. The only difference is when we add A and B together, those probabilities, we subtract the intersection of the two, so we subtract the overlap, okay? Then the multiplication rule, okay, this is the AND scenario. So this is the probability of A intersect B is equal to the probability of A times the probability of B. Okay, and again, this is only if A and B are independent. Okay, we have one as well for when it's not. Okay, and we'll get those in the chapter 15 questions. So I'm going to go back through really quick and just highlight these numbers. Okay, anything that we just did, obviously. Oh, sorry. All the ones that we answered, you need to know. I'm trying to just do highlighted ones right now. Okay.
Oh my gosh.
On the next page, the only one you have to know is 18.
How do I edit? What am I doing?
So you only need 18 off of this page. So explain the difference between the union and the intersection of two or more events. The union is the event that any of them occur. The intersection is the event that all occur. Okay, so the difference is any or all. On the chapter 15, it's going to be 2, 4, 5, 6, 8, and 10. We have these. Okay. All right, 2. In general, whether events are disjoint or not, what is the formula for finding the probability of A or B? Oops, not the highlighter. Hello. Probability of A union B. Okay, so A or B is equal to the probability of A plus the probability of B minus the intersection, probability of A intersect B. For what is meant by joint probability, the probability that two different events are related. I know I'm going fast. I'm trying to get y'all as much of this as possible for today. Conditional probability, the probability that takes into account what?
I said it's okay. I still have another hour with you.
Takes into account a given condition. Okay, and mathematically that would look like the probability of B given A is equal to the probability of A intersect B divided by the probability of A. Okay, 6 is basically the same thing. State the formula. Probability of B given A is equal to the probability of A intersect B divided by the probability of A. Okay, and we say the probability of B given A. Here, I'm going to write the last two, and then if I need to post this for y'all so that you can just see it, I'll just make sure it's posted. Formula for A and B, so it's the intersection. Probability of A intersect B is equal to the probability of A times the probability of B given A, which is the probability of A times probability of A intersect B over the probability of A. Okay, this is where it's derived from. And then 10, if y'all need to go, I really can post this for you.
No, it will be okay. He states we have history.
All right, say the formula to determine whether two events are independent. It's independent if the probability of B is equal to the probability of B given A. Or we could say the probability of A is equal to the probability of A given B. Okay. So those are the questions you need. If y'all don't get it and you need it, I can airdrop it to you real quick or something if you need it.